All right, hey everyone. So this is just kind of a review for the final exam. I'm going to kind of talk about the dates and the practice exam and kind of get you straightened out on all of that. So the practice exam, uh, first let me go to the home page. So I posted a video, a help video for Lab 10. Some people were getting hung up on concentrations and mass percentages and stuff like that. So I wanted to do a help video just to kind of get you all the way through that. All of your work is due May the 1st. Okay, May the 2nd is the last day of class, and I hope to get all the grading in then, get all of the grading done by then, so that you'll have a good idea of where you stand coming into the final. I'm also going to post the practice exam under quizzes, so the same place where you took the midterm exam, it'll be here, and it'll be available starting May the 3rd. So that'll be Tuesday, May the 3rd. Make sure I got my dates right. May, yeah, Tuesday, May the 3rd, and it'll be open all the way up until the final starts on Friday, May the 6th. Okay, so Thursday at midnight or Friday morning first thing, I'm going to grade and return all of the practice exams. That way, you get to see what you missed or how many bonus points, or you'll get to keep up with kind of where you're at. And then you'll be able to go back in there and click and look at the answers and see what you got wrong and start getting ready to take your final. The final will be available May 6th. That's a Friday from 6 a.m. all the way until uh, I think I said May 9th, Monday at midnight. Okay, so that's 4 day stretch, Friday through Monday. Anytime in that period, you can go in there and take your exam. It'll be here under assessments, quizzes, just like the midterm was, and you'll have 2 hours to complete that exam. Okay. Um, I've also posted, if you go to content, so this video I'm going to post on announcements, and I'll also include the dates of the practice exam and the final on my announcement as well. I'm also going to put this video in the content under final exam. So I posted a study guide, which is here under content. Um, and that's kind of what I'm going to do for the rest of this video is go through the labs and the study guide, and just to make sure that you know exactly what you um, need to study for the exam. Okay. All right. First up, we have Lab 5, and that is dealing with chemical reactions. Okay, so I'm very straightforward on the study guide. Just if you can do all of these things, then you're going to do very well on the final. Okay, another good resource will kind of be um, Chem 21 Labs itself. Okay, go through there, make sure you understand what went down in the experiment. Post lab questions are always a good um, review for the exam, because it's typically asking you about the concept that I wanted you to learn, or having you do problems like what you're going to do on the final. Okay? So I'm just going to go through each one and kind of make sure that we are on the same page is what I want you to know. So I've been able to recognize all of these reactions might be helpful. I usually don't use the exact same ones here, but it'll be something that you've seen before, right? So be able to name the type of reaction. Is it a decomposition? Remember, that's when they break apart. Single replacement, right? I move one element to another compound, okay? Double displacement. I switch both elements from each compound to the other one. And then also have go back through. Let me see what the PDF lab guide, if it has a little list. You also want to maybe make like a little cheat sheet, right? So that yeah, it has a little list of all the different types of reactions, combination reaction. I put them together. I probably won't do much about reduction oxidation, because those can be hard to recognize if you're not familiar. See, looking at this, you might think that it's a straight up combination reaction. But we actually change the state. When iron goes from solid to this iron oxide, it changes the number of electrons. It goes from iron 0 to iron 2. But that's beside the point. Don't worry about reduction oxidation. Okay? Combustion reaction, I like to ask that one because it's easy to recognize. Oxygen, anything that burns in the presence of oxygen is going to create water and carbon dioxide. And that's always a combustion reaction. Okay? Okay, be able to, let me go back to the study guide. Be able to recognize, determine charges for chemical reactions. What is the charge of an ammonium ion? All right, so one thing you might ought to do with your list, of the types of reactions is a list of polyatomic ions. Okay, couldn't hurt because a lot of people will go in there and they'll see this hydroxide ion and they'll try to break it up into an individual oxygen and an individual hydrogen, and that's not what you should be doing. Okay, polyatomic ions move together. Okay, a phosphate on the reactant side of the equation is still going to be a phosphate on the uh, product side of the reaction. Okay, so it's going to move as one kind of element. You can just imagine it as it being its own little compound element, and it doesn't break apart. So have your little list of polyatomic ions, be able to recognize them, be able to determine charge. Remember we went over like valence electrons. If I lose two valence electrons, then I become positively two charged. Okay, so it's important that you kind of remember that. Be able to be able to balance chemical equations with the proper coefficients. So one thing I like to do, and I may do this on the practice, I'll probably do one on the practice and some on the final as well, but I'll put like an equation with blank spaces in front of each compound, and then you have to go in and fill in the coefficient to balance the equation. So be familiar with that, be able to balance equations. I usually don't do anything as tough as this combustion reaction you see here, right, with 13 halves. Um, it'll be something much more straightforward, but be able to go in there and plug in these coefficients in the red right there. Okay, 4 carbon dioxide, 5 water molecules. This is just an example of a combustion reaction, but it's also useful just to kind of explain this is what I'm looking for, the coefficients when you're balancing an equation. Okay? Be able to identify types of reactions. We mentioned that. That's a combustion. Remember, anything with oxygen that results in carbon dioxide and water is a combustion reaction. Also, be able to recognize the state of matter. So, um, if it is G stands for gas, this L right here stands for liquid, the S stands for solid, and then AQ stands for aqueous. Okay, so that's multiple choice, 4 different answers. That's very likely going to be a question on the final. All right, let's go to lab 6 and look at it. So this is the rates of chemical reactions. And this one we had you look at different reactions when we changed the temperature, we changed the concentration, or we added a catalyst, and then you saw that a higher temperature made the reaction go faster, a higher concentration made the reaction go faster, and then adding a catalyst also made the reaction go faster, but it does it for a little bit different reason. So go back and look through your PDF lab guides. There's usually a section that explains the big idea concepts behind each of the lab. For this one in Catalyst, it was the lowering of the activation energy, right? So when we lower the activation energy, it lets the reaction go over the hill smoothly, more quickly. So that's what makes the reaction go faster. So in this sense, I could ask about a catalyst. What is a catalyst? What does it do? I could ask about the activation energy. How does the catalyst affect the activation energy of a reaction? It lowers the activation energy. I always think of the activation energy as being this hump right here on this graph, right? The highest part, however much it has to go up, that's how much energy it has to spend to activate. And when I put a catalyst in there, I'm this red line. Oh, you can't see me. I'm this red line here, and it's lower than without the catalyst. Okay, so be able to kind of recognize that. I might ask general questions like, if I raise the temperature in this reaction vessel, will the reaction go faster or slower? If I raise the concentration, will the reaction be faster or slower? Stuff like that. It wouldn't be nothing too complex. Yeah, and then all that's just kind of big idea stuff. If you understand those concepts, you should be fine with this section. So understand how concentration, yep, what is a catalyst, what is activation energy, that's good for that. Usually not as many questions from that section, but there will be some, obviously. Next, we got Lab 7. This had to do with the Gay-Lussac's law. I don't know how to say it. Temperature versus pressure in gases. Okay, so this is just remembering that as the temperature goes up, the pressure will increase. Okay, and that's because those molecules are starting to move faster and faster. Temperature is just kind of how fast these molecules are moving. And as it gets faster and faster, as the temperature goes up, am I still? Yeah, as the temperature goes up, then the pressure is going to get higher and higher. Okay. Now, there's other laws that we learned in lecture, right, about like Boyle's law and Charles' law that has to do with temperature, pressure, volume. Um, for the lab exam, I'm only asking you what is here. So be able to predict how varying temperature will affect pressure, right? If I lower the temperature, will the pressure be lower or higher? If I raise the temperature, will the pressure be lower or higher? Stuff like that. Um, and then be able to convert your units. Remember when you did this in lab, let me pull this up. When we did this in, oh, that's lab 6. Hold on. Lab 7, I had you convert pressures. Your pressure was given in pascals, and you had to convert it to millimeter mercury. The temperature was given in Celsius, and you had to convert it to Kelvin. So be able to do both of those things, right? Be able to convert temperature and pressure. Um, so you may want to, well, temperature, you may want to write down like on your little cheat sheet the conversion rates. I will probably put them on there, I would assume. Um, but it couldn't hurt because you're going to need to study, and so it'd be a good idea to kind of practice those specific problems. Convert different pressures back and forth, and then convert temperatures back and forth. Let's see what the post labs were. Um, Kept constants. We did the graph, the molecular velocity and collision of molecules. Okay, that's what I was just mentioning there at the beginning. Let me pull myself up so I can kind of illustrate this with my hands. Do I got any? I got some little atoms here. Uh, Hold on. Okay, so imagine these are little atoms, and this is the whole concept behind the Gay-Lussac's law. Okay, these little atoms are moving around in, let's just call it a solution of water. Okay, these are two little water molecules. All right, and at a certain temperature, they're just kind of moving back and forth, bounce. 2 seconds. Let me put this dog up. I apologize. I've already had to redo this video like 3 times because of this dog. I'm watching my brother's dog for the week while they're in Italy or something. All right, Gay-Lussac's law. So these are the water molecules, and they are in a solution. And as the temperature gets higher and higher, they move faster and faster. And so what that does is makes them start bouncing off the walls harder and harder, and that's essentially what pressure is how much force is being expelled on the walls. Think about a balloon, right? The more pressure is in that balloon, the bigger it gets because that force is pushing out more and more and more. So that is the concept behind um, molecular velocity and collision. So that was the question they asked. I probably won't do anything have you explain it like that, but it's good for you to know and kind of understand the concept behind um, these physics. And I'm not really worried about the constant K. All right. Next up, lab said we skipped lab 8, we skipped lab 9, and we did titration. All right. So titration, you got a lot going on here. You're going to need to know how to uh, identify the acid and the base used in this specific experiment. So I'm not going to ask you about anything else except for acetic acid and sodium hydroxide. Okay, and that's going to make several things easy. Number one, the molar mass. The molar mass of acetic acid is 60. It's very easy to remember and use. I will provide it though. Most likely, I will provide it anyway. But if you're doing any practice, you ought to remember that fairly easily. NaOH, the molar mass of NaOH is exactly 40 grams per mole, so that makes that easier to use in calculations. And then the ratio, the mole ratio of combining NaOH and an acetic acid is 1 to 1. So I'll have the same number of moles once I've run a neutralization experiment and reached the endpoint. Then I'll have the same number of moles of NaOH as I will of acetic acid. And so anybody that goes through this experiment and does that, you ought to recognize that immediately. This is a 1 to 1 ratio, and I have the same number of moles of NaOH as I do of acetic acid. All right, so you're also going to need to be able to transfer grams to moles, be able to use molar mass, molarity, be able to convert volume, milliliters and liters, and vice versa. And then be able to kind of recognize the steps in the titration. Okay, the first step was we took a standardized solution of NaOH and it was 0.5 molar, and I put a certain volume into acetic acid, and then that let me know exactly how many moles of NaOH I had. Since I have the same number of moles of acetic acid, I could back calculate what my concentration of acetic acid was. So I'll probably break those down into different questions at certain points. Maybe I'll give you the mass of acetic acid and the mass of the vinegar and ask you to calculate mass percentage. Maybe I will give you the volume of NaOH that we used in milliliters and then ask you to figure out how many moles of acetic acid I have. And that requires you changing it into liters and then back, back calculating moles based on molarity or molarity or molar mass if you're going the other way. So different things to know here. This will probably be the hardest and most complex of anything that we've done in this class, but we've got to keep pushing you and taking the things that you've learned so far and trying to apply them um, in the real world. And that's what it takes. You have to combine all of these different knowledges and come up with solutions and be able to, you know, really break down different aspects of an experiment. So let's go to the study guide and make sure I didn't miss anything. Be able to identify the indicator. So let me go back to that real quick. The indicator is called phenolphthalein, and it should be listed here. Right here. Okay? Phenolphthalein. And so I might ask you what color something is. If I say I have vinegar with phenolphthalein in it, but I have more acetic acid than NaOH, what color is my liquid? It would still be clear. If I have more base than acid, it'll be pink, right? So kind of watch that experiment again and make sure you understand what the indicator is doing, why is it doing it, and what the color change was for phenolphthalein. Okay? So next up, be able to explain the titration experimental setup. So that's what I was just talking about. We put the NaOH in the burette, and then we put the vinegar in the flask. Um, the stopcock is what you turn to open it up. I doubt I'll ask anything particular about like the equipment that we used, but maybe it'd definitely be helpful to know it. Be able to convert milliliters to liters, moles to grams using titration calculations. I mentioned that. And determine the volume or molarity of an acid needed for neutralization. Yeah, if you can work through that whole experiment, do the math behind all of that, you should be good. So that's all of that there. What was the PDF lab guide? Make sure there wasn't nothing extra there. So yeah, these PDF lab guides are really helpful. Um, they explain everything and really walk you through the experiment just as much as my videos do. So there's your chemical equations of what's going on. Be able to recognize that a combination of acid and base leads to water, right? That's a very important aspect of a neutralization reaction. Be able to identify a neutralization reaction. But that was back in chapter 5 as well, right? Types of reactions. So that kind of covers two different sections. All right. I think that's about it for review. Um, Let me see if there was any post lab questions here. Yeah, these post lab questions are a little tougher, but they very close to what I might ask on the exam. So might want to go through there and kind of work those. Like I said, I'll get these graded. I think everybody, this one's not due till the first, so this one will probably be graded on the last day of class on the second. Uh, but if you have any questions about this one, email me, this weekend, and I'll try to walk you through it. And like I said, I also posted a video for Lab 10 help, and this kind of is a example problem. So it would also be a good idea to go check that out and kind of make sure that you can follow along and that you can work these uh, titration problems on your own. All right. So that's it for me. I'll be around all weekend though. If you need some help, just email me and I'll get back to you as soon as possible. And then if you need to set up a meeting or a Zoom meeting or whatever and go over some problems, then I can do that. Probably be sometime like before the final. We can set it up for early next week. I don't know how much I'll be able to meet this weekend, but just email me and let me know what kind of problems you're having and how I can help. All right. So that's it. I will see y'all next week. Bye.